This first lesson is called Interpreting Two-Way Frequency Tables. So, step back to like the beginning of probability with me. Just remember, when we do probabilities, we're looking for the target over total. And in the last unit, Unit 9, we did some really complex probabilities. These are going to be back to when they were very simple, just the target number over the total number of outcomes, possible outcomes. So just remember that, target over total. And then the good news is everything's going to be given to us in a table. So we're going to be dealing with our data laid out visually, and we just have to interpret the table and find the parts we need to set up our target over total, our probability for that question, and we're done. So today we're going to be defining a two-way frequency table, solve probabilities using these tables, and I guess that's it. Bailey, good morning. Glad you made it. So just a reminder, this is the first lesson of Unit 10 called Interpreting Two-Way Frequency Tables. Here we go. So definition, what is a two-way frequency table? A table that will be showing data for two different variables. So that's kind of the important part here. There's two different variables, two different types of information being given. So we're going to have to examine and be able to tell the difference between these two variables. Use a two-way, we can use a two-way frequency table to find different probabilities. And then this is important too. The two-way frequency table will have independent and dependent information for different types of events. So some of the information is dependent on each other and some isn't. So let's look at our first one, and we'll try some practice questions for our first two-way frequency table. So here's our first table. Assume that 750 people were tested for heart disease and had their cholesterol levels checked. Those are the two variables. The order that you label these doesn't matter. So one of the variables is going horizontally. That'll be heart disease in this question. The second variable is going vertically. Cholesterol in this question. So the two variables are like the two different questions on this survey. So the first one is just about heart disease. Do you have heart disease? Yes or no? And then you can see the data laid out for those people. So it looks like how many people in total had heart disease? 234. How many people in total did not have heart disease? Can you tell me in the chat or verbally if you can see that in the table? How many people did not have heart disease? Do not. How do we find it? Well, here's heart disease on the left side. Here's the section we're interested in, not heart disease. There's a bunch of numbers listed here, right? But which one is the total of those no's for heart disease? I see one chat. Aaron, good. Thank you. Yes. 516 is the total number of people without heart disease. So what are the other numbers there for? What is the 367 and the 149 there for? That is breaking that 516 people into two different categories for that second variable. So it's like giving a survey to a bunch of people and having two questions on it. Do you have heart disease is one question, yes or no. And then also, what's your cholesterol level, normal or high? So they had to answer two questions, and that's why this is two variable. There may be more than like two options for each of the variables. So sometimes there'll be 3 or 4 or 5 different columns under the vertical one, or rows for the horizontal one. And then we didn't really look at the cholesterol, but if we look at the cholesterol question, that's all the stuff going down vertically. So the answers to that would have been normal or high. And then we can see those totals at the bottom. So there's 378 people with normal cholesterol, 372 with high cholesterol. If we add up the totals on the bottom or going down the right side, they both add up to the total number of people asked. Total people in the study or the survey. So how do we do probabilities with a table like this? If we were asked what is the probability of picking one person uh, who had heart disease and had normal cholesterol? Had heart disease, so that's a yes on heart disease, and normal cholesterol. So where do those meet? 11. There's 11 people, that's our target. There we go. Out of how many total people were there? 750. So that's how we can set up probabilities for using these tables. Let's look at some different questions with the same information. Here's 3 different questions to practice with. Question 1, probability that you pick one person and get someone with high cholesterol. So what's the total number of people with high cholesterol? That's our target. Out of the total number of people altogether. So how do we set that up? What's the total number of people with high cholesterol? 372. Total number of people altogether, 750. So there's our fraction. We could reduce it down. I'm just going to cut to the chase and divide it. Maybe someone else did in the chat. Good, Aaron. Very good. Good setup. And we could reduce it down. We should practice doing that just because sometimes in Inventum, they give us fraction answers, right? And they're not going to say 372 over 750 if it's not reduced all the way. So let's actually practice reducing it. So I'm going to cut this in half. I see they're both even. So 186 on top, and then 750 cut in half. 375. Okay, we can't divide these in half because 375 is not even. It's not ending in a 2 or an even number. So let's try dividing them both by 3, see if that gets us anywhere. It did. It worked. So I tried dividing top and bottom by 3, and I got 62 out of 125. And that's probably it. Well, let's try a couple more. Try divided by 3 again. Nope. 5 will not work. Try 7. Nope. Try 11. That's not going to work. Try 13. And then we can stop. Yeah, looks like we've hit the end. So as a fraction, our answer would be 62 out of 125. Divide it to get your decimal. Looks like 49.6%. Okay, another simple one for number 2. Probability that you pick one person and there's no heart disease. So total no heart disease is 516 out of 750. Five 16s, try dividing by 4. That did not work for 750, so we'll have to cut them in half. Try dividing them by 3. $86 over 125. And that would be the end. Then to find your decimal. 86 divided by 125. 68.8%. Now for a slightly more challenging question, number 3. So pay attention to the wording in the question. This has a given that. So with the given that's, that'll change up what our total is that we use. Find the probability that a person has normal cholesterol, target, given that they do have heart disease. So that means we're only looking at the people who already have heart disease. Given that they have heart disease means we're kind of narrowing our focus to this row. And we don't care anymore about the entire study. We're saying, assuming that you have someone who already has heart disease, what are the odds? What is the probability that they have normal cholesterol? So normal's our target over the total of 234. A very low probability. It looks like people, assuming this information is true, it looks like people with heart disease don't normally have good or normal cholesterol. Those are outliers. 11 divided by 234, it's only 4.7%. So that means there's probably a link between having high cholesterol and having heart disease. So pay attention for given that. If it says given that, then you're narrowing your focus to just that section for your total. This would be an example of a dependent situation to link it back to what we did in Unit 9. Because having normal cholesterol or having any type of cholesterol does depend on, in this case, whether or not they had heart disease. So that changed our total that we used. Let's try another example. Same information. Find the probability that someone, a person, has high cholesterol given that they do not have heart disease. Try this one on your own and type your answer in the chat. Fraction or decimal is fine for your answer. Tell me what you can find for this. Find the probability that someone has high cholesterol given that they do not have heart disease. Remember, the given that is telling you to narrow your focus to that section for the total, to that row or column. So if we see given that, That tells us to only look at that row or column for the total. All right, and no one is saying anything. So let's try this again.
Wait, what happened? I'm sorry, I had to go get my charger from my computer.
Oh, it's okay, Aaron. I was asking everyone to try this question on your own and just type your answer in the chat, either as a fraction or the decimal. But it's not just you. I'm not getting any responses. So let's do this in a step-by-step way. Asking for a probability, so we know we want this. Target over total. What's our target this time? Find the probability that what? What's just the target? Probability that X is happening. What are they asking for?
The high cholesterol.
Okay, thank you, Aaron. Yes, that's so high cholesterol is our target. Our total, normally we would take the 750. However, it's saying given that they do not have heart disease, that's a clue that we need to just focus on that section. Do not have heart disease. So then we say, okay, we're only looking at the people that do not have heart disease because of that, given that in this question. So we're only looking in that row in this case because of the given that. So we're looking at 516 for the total. And the high cholesterols, we're not going to take the total number down below. No, do not take this one because that's including this 223. That's including people who have heart disease. And we don't want people who have heart disease. So we're only looking at the 149 for our target. So when you see given that, I want you to focus just on that row or column. Nothing else matters for that question if it's a given that question. I see a chat. Let's see here. Thank you, Antonio. Good. Very good. So our total is the 516. And our target is the 149. Because we're only focusing on those non-heart disease folks, but the high cholesterols within that group is 149. So that's the main takeaway from today. Normally we use the entire table. Normally we use the 750 total at the bottom corner, unless it's a given that question. And then we're only focusing on that row or column, the one that it says given that. So let's see, 149 out of 516. Let's just divide it. Looks like 28.9%. To fill in my notes here, I was saying target over total, and that's going to be the high cholesterol people over the non-heart disease people. Total number of all non-heart disease people because of the given that. And then that kind of changes our thought process for the target. It's not all high cholesterol people, it's the high cholesterol people within the non-heart disease people, the 149. I think it's easier to just focus on, like, if it says given that, temporarily block out the rest of the info from your mind except for just the given that's row or column. Let's try another one together, guys. Let's look at this. I've got some new info to play with. So before we look at the questions, let's examine the table. It says it's about type of flower and the color. And then if we look down, it's types of flowers, roses and hibiscus flowers. So those are like the types. Going vertically, we've got colors. So maybe this is a flower store, or maybe we're ordering off of a website, but we've got these three choices. We can have red, pink, and yellow, and we can have red, pink, and yellow of roses or hibiscus. So remember, if the question says given that, only focus on that row or column. If it doesn't say given that, we're going to use the main total. Let me write that in here, the main total, the total of everything. So that means there's 315 total flowers here, a mix of all those colors of those two types. So let's try number 5, unless there's any questions. And if there are questions, please jump in and let me know. So for number 5, find the probability that a flower picked at random is a yellow hibiscus. And it's specific. It's not saying just a hibiscus, and it's not saying just yellow. It's saying specifically a yellow hibiscus. So, how many yellow hibiscus are there? Can you see that in the table? Yellow, go down. Hibiscus, move to the right. 90. Let me see that, chat. Aaron, very good. 90. And you even said the whole thing, 90 out of 315. Let me just lay that out real quick. Yellow hibiscus, how many are there? There's 90. And total flowers is 315. And there's our setup. Then what do? We want to reduce the fraction. Let's try dividing this one by 3 from the beginning. 315 divided by 3 worked. So it looks like it's 30 out of 105. We can divide that by 5. That'll be 6 out of 21. Yeah. And I think we could divide by 3. So 2 out of 7. So there's our fraction answer. Divide it, 28.6%. 28.6% chance of randomly picking one flower and getting a yellow hibiscus. Now try number 6 and notice that it's a given that question. When it says given that, only focus on the given that part of it. Find the probability that the flower is red given that it is a rose. So given that it is a rose means we only care about looking at the rose information right here. Nothing else matters for this question. In the chat, Aaron is on point, 40 out of 120. Right setup, Aaron. Double check your total. Right idea. Yeah. Good. So then we use the total number of roses, and then we're only looking at the red ones. So all the reds out of the roses. 40 reds out of a total of 105 roses. And then we would reduce it down and find our decimal. Let's see number 7. Find the probability that a flower picked at random is pink. So then It's not saying given that, so we're back to the entire table. We care about all the flowers. All the pinks, how many pinks are there? There's 60. Total number of flowers, 315. So it's 60 over 315. And as a decimal, 19%. Now, that is basically it for today. I think this one is almost a little too easy compared to how hard they make other lessons sometimes, like how much information. So we've got 30 minutes. I'd like everybody, regardless of your progress in other units or anything, let's all do this mastery test together now. See if we can knock it out. I've got all the questions ready. So if you have a question that you want to ask about or check your answer on before you submit it, let me know. But let's do that mastery test.
I'm in the middle of a math test.
You're in the middle of the math test. I was hoping you'd be doing this lesson with me and not your math test right now.
Well, I've been paying attention.
Good. Okay. Can we do the mastery test now?
I guess I could do a mastery test.
Awesome. Yeah, let's all do the mastery test and get it out of the way, and then you can finish your math test. If you want to ask about any questions while you're doing the mastery test, let me know.
Okay.
Okay. Oh, I just realized one thing that I want to just review with you guys real quick. It's nothing actually new, but it's been a while since we've used it. So the given that questions, remember how we set that up in our like equation format? Here, let me go back. Looking at number 6 here that we did earlier today. How would I write that using the proper probability annotation? The given that is written like after the straight lines. So how would I write number 6 using that? It would look like this. Probability, P, of picking a red, given that you've already honed in on roses, given that you've already chosen roses, given that it's a rose. So when we write it out, the second part, the given that part, goes after that straight vertical line inside the parentheses. I see one question, maybe more, that will use that. So if you get that question and you want help on it, feel free to ask and we'll do it together.